This is video 207. It's about the action called PECK. PECK is going to pick a random sample from a population where all the observations are equally likely. That's what the E's about. Or from a population that is normally distributed around a mean and a standard deviation. Here is the routine. It's going to use the tick value t to tell it to make the observations once every 2.5 seconds. T, as you know, is about a value that's increased every 20th of a second. So if we tell it to go from 0 to 49 by putting a 50 here, we're going to make our observations only when it's 0. Here is what we use. We say branch if not equal to 0 to EC, which is to go home. So only one time in 2.5 seconds will it be 0, then it do its recalculations. PECK needs a seed value. Well, to generate a seed value, we're going to make sure that S, the seed, is a positive value. Then we're going to make sure it's between 0 and 999 by modding it with 1000. But each time we make the observations, we're going to add 1 to that seed value so that the next time we get different results because we're starting at a different place. N is going to be the number of possible observations. We say 10. That means the values that we get from the population, which is equally likely, will be from 0 to 9. We're going to fill counters in the list called observed, all 10 of them, with 0. Now we're going to go around a loop 1,000 times. Each time we're going to get a random sample from the population where the value could be from 0 to 9. This P value observation will be from 0 to 9. Then here's the counter in list observed. At offset 0 to 9, we will add 1 depending on what was observed. Okay, that's equally likely. Next, we're going to have the case where the observations are normally distributed. Well, at A3 here in PECK, we had the number of possible observations. Well, if we set that to 0, it then knows that PECK is to use a normal distribution, and that the value after that will be the mean, and then the standard deviation after that. So this time, instead of adding up every possible observation, because it's from a normal distribution, there are thousands of possible observations. So what we're going to do is when we get a value from this normal distribution, we're going to divide it by the standard deviation. That's going to give us our index for observed count, but this time that observed count is going to start at offset 20 and then get added to it the offset for that area of the standard deviation. Again, we're going to go around this loop from 1 to 1,000, so there's going to be 1,000 observations. Alright, we're now going to execute this application. We're not going to go to the trail because it goes around those loops 1,000 times. We're just going to see what the data is. So we're going to say data, work list, the work list called observed. These numbers will change about every 2.5 seconds. At offset 0, we put the observed counts that were equally likely. Well, there were 1,000 observations, 10 possible observes, so therefore each one should be around 100. Notice there's some more than 100. Well, there's one a lot less. But you expect there to be 100 of each. However, the other ones, remember, were put at offset 20 for the normal distribution. Here is the value that says how many of the 1,000 were within one standard deviation below the mean. Here is the value of those one standard deviation above the mean. Remember, the value 100 was the mean. Then, next would be 2 standard deviations above the mean, 3 standard deviations above the mean, 4 standard deviations, and there's none 5. It's not likely to be any 5. Okay, on the other side, within 1 standard deviation, how many were in the 2nd standard deviation, the 3rd, the 4th, and again in the 5th? That's very unlikely. Alright, that is video 207.